So for this video, we're going to be practicing more of solving these literal equations. So first I have 5y plus 4x equals negative 15, and I want to solve for y. So I want to get y by itself. And so when we're doing these, we always want to treat this like a normal equation. So I can relate this, for instance, to 5y plus 4 is equal to negative 15. If I were to solve this for y, I would subtract the 4 first. I'm going to do the same thing here. So I'm always going to move whatever is being added or subtracted first. I want to subtract 4x from both sides. So I have 5y on the left-hand side. Now here we need to be careful. One of the common mistakes I see from students is they like to put negative 19x here. However, that is not correct, and that is because this negative 15 doesn't have an x with it, so I can't actually combine them. So instead, I'm going to put negative 4x minus 15. You could put negative 15 minus 4x instead right here, but when we get later on into our linear equations unit, we are going to have it in this form with the x term first and the constant second. So I would go ahead and get used to writing it like this. Okay, and then next I want to get rid of this 5, so I need to divide. But here's another place where we have to be careful with literal equations. When I'm dividing 5 on this side, I need to divide 5 from every single term. And so I end up with just y on this side. Here I have negative 4 divided by 5. I can't reduce that fraction, so I'm just going to have negative 4/5 x. Negative 15 divided by 5, I get minus 3. Okay, let's try another one. So this one, I have 6y equals 3x minus 4z, and I want to solve for x. So I want to get x by itself. My first step is to always move what's being added or subtracted to my x. So I want to move this 4z. So to do that, I have to do the opposite operation. So I need to add 4z to both sides. So I have 6y plus 4z is equal to 3x. Again, I can't combine these to be, for instance, 10yz, and that is because these aren't like terms. They're different variables. So I have to instead leave it as 6y plus 4z. And then now to get x by itself, I'm going to divide every term by 3. And so 6y divided by 3, I get 2y plus 4/3 z is equal to x. Another way I could write that is to instead have x is equal to 6y plus 4z all over 3. Either answer would be acceptable. The only time I really want you to go ahead and divide every term is when it's just in terms of y and x, because again, when we get to our linear equations unit, we're going to have to leave it in this form. So go ahead and pause the video. I want you to try number 3. I do want you to have it in this form right here. When you think you got it, go ahead and press play. So the answer you should have gotten here was 16y plus 5/6 is equal to x. You could have left this as y over 6. Either way is fine. Again, when we get to later units, you will need to have it as a fraction out in front. And the way I got that 1 is that there is always a 1 in front of any variable that doesn't have a number in front of it. There's really an invisible 1. Okay, now for this last one, I again want to solve for x. So this one I have a few more terms with it. So I want to get x by itself, so I need to move whatever is being added or subtracted to it. I'm going to go ahead and move my k first. You could move your 3. Either way, you're going to get the same answer at the end. So I have 3 plus 5x is equal to, again, I can't combine these, so I'm just going to leave this as y plus k. Next, I'm going to subtract the 3. So I have y plus k minus 3. And then I'm going to divide everything by 5. This time I'll go ahead and show it in that form. So I have x is equal to y plus k minus 3 all over 5.